Greetings, this is Rick Powers, coming to you from my home office, working on explaining the idea of a confidence interval, how it works, what it's like. I'm going to share my screen now so that you can see an example. I'm going to use some technology in order to demonstrate confidence intervals. So what I have here is on the top graph, I have a list of 100 different people and their ages. And what I'm looking at here, it has a particular mean of approximately 43. And it has a standard deviation, and technically I'm treating this as a population. This is all of my people. So population standard deviation is 12.3. Now, when I'm working with this, I'm going to ask a question. What happens if I take a sample of this? And when I do a sample, I'm going to be able to, as you can see here, I'm going to be able to choose my sample size. And my sample size for this is going to be 64. And I'm going to see what happens when I take a sample and then find the mean of that sample. So I do a one-time sample. And here's my sample of 64, which was taken out of these 100. And I come up with a mean of 41.3. Well, that's not 43. It's off. So the sample mean is not the same as the population mean. Although it's close, it's not the same. Well, what happens if I do it again? It's once again different. Now the mean is 44.6 for this sample. So it's quite a bit higher than 43. So then how would I know the population mean if all I have is a sample? And the answer is you don't exactly. What we want to do, though, is we want to come up with an interval that we think will include the population mean. So what we want to know is, what is the distribution of the sample means? Well, this is just what we did last lesson, is that we said the distribution of the sample means with this sample size of 64, it would have the same mean, but a smaller standard deviation. The standard deviation is not going to be 12.3. It's going to be significantly less than that. And specifically, it would be 12.3 divided by 8, because that's the square root of 64. So if I take that, 12.3, and divided by 8, that's going to give me a standard deviation of the sample means is going to be approximately 1.5. Now, we can make this happen pretty easily. We can keep taking samples. We can take 5 at a time. And as you can see, it's not exactly bell-shaped right now, but it looks like it's pretty close to my 43. In fact, 43 is the mean. But if I do it 1,000 times, right, then I'm just adding thousands of samples here. And you can see, yes, it is bell-shaped. And the standard deviation does come out to be 1.5, which I assumed that it would be. Okay, so I want to use this, though, in order to do an interval estimate. I want to say, what am I going to do if I just take one sample? How will I know that what the population mean is just from that one sample mean? Well, I'm going to use an interval. I'm going to use something above and below that sample in order to estimate where I think the population mean would be. Now, clearly, if I just do 1.5, that would just be one standard deviation on each side. I'll probably want to go higher than that. I'll go 2 standard deviations. But notice this standard deviation is 12.7. It's not 12.3, because the standard deviation is different, just like the mean was different. Okay, it just stands to reason that this has a mean of 43.8 and a standard deviation of 12.7. So it's like there's an extra layer of uncertainty that's involved here. And we'll talk about that a little bit later when we talk about the technology. But for right now, as you can see here, when I take one sample, I'm not going to exactly get the mean, but I'm going to be relatively close, and I can have an idea of how close I need to be as far as the above and below in order to say I think the population standard deviation is here. Now, here in this particular software, though, I'm able to actually come up with these confidence intervals to see what they actually look like from all of my different samples. So again, I have a sample size of 64, and I'm choosing my confidence level to be 95%. I put that into a formula or use technology, and I get a bunch of confidence intervals. So I'm going to graph 100 different confidence intervals. And it looks like this. As you can see, they're basically from around 40 to 45 or so. And I can click on one of them here, and you can see it's from 42 to 49. Okay. Oops, that wasn't the right one, I don't think. Yeah, this is from 43 to 49. Oh, yeah. If I'm going from like 41 to 48 or something. So I did, most of these worked. Most of these gave me a result that actually did go over the population mean, but not all of them worked. Okay, this one was from 43.8 to 50. So it did not include the correct number. So for this particular sample, if this was the sample that I had actually done, I'd be wrong. Okay, so you have a chance of being wrong. That's why we call them confidence intervals, okay? Because we don't know for sure, but we're relatively confident. When I do a sample, I'm going to be about 95% confidence that it will give me the answer. And that's why this is a 95% confidence interval. Because as you can see, out of the 100, only 4 of them work. So most of the time it does work. And I can change this if I say, well, let's be 99% confident. Okay. Well, 99%, yeah, it looks good. Well, let's reset that and try again. Do they all work? Well, they do. All of them out of 100. How about out of 1,000? Well, 98.45% of them. So yeah, a lot of them worked. So if I want to be more sure of my results, I will change my confidence interval to be more confident. But what that will do, if you notice, these green lines are larger. Because if I have a larger green line, then I'm going to have more ability. Oh, but here's one that missed. So I'm not 100%. Otherwise, all my green lines would be too long. I'm 99% confident that I'm getting an answer that will have the population mean inside of it. Well, that's good. All right. And if I change this to be just 90%, right? The green lines are smaller, but I have more of a chance of being not accurate. So here I'm missing more of them. So I need to reset this. So yeah, here, okay, there's a bunch of them that they're not giving me the right answer. Most of the time, though, I'm getting the right answer. So there's a balance between how wide the green line is and how often I hit my target. But I don't actually know if I hit my target. When I use a confidence interval, I can't tell you for sure that it's going to work. But I can tell you I'm confident that 90% of the time it would work, or 95, whatever I want to choose. All right, so now we're going to reset this. And we're going to change this so it's not a sample size of 64, but it's a sample size of 6. what happens when I only have 6 things? Well, there's only 6 things going on here. So that's just, I don't have as many numbers here. And so then my results are not going to be as accurate. I can do the 6, but then when I get my results, they're going to be more variation in there because I'm only picking 6. And so it's possible that my results will be substantially off. So that means I will need a wider confidence interval. Well, let's see. Do I have an option here? I don't think I do. But can I do 1,000? Yes. So here I did 1,000. All right. And you can see that this is quite the spread out possibilities for my samples because it's 12.3 divided by the square root of 6. So that comes out to be more like, well, it's bigger, basically. We can just not worry about the numbers right now, but we can see that this is a wider possibility. So my samples are spread out more. So that means I'm going to have to use a wider confidence interval. So if I take a look at my confidence interval, try again. If I take a look at my confidence interval then, based on this, so now if I say I want a 95% confidence interval, but my sample size is just 6 instead of 64, well, then they have to be really wide by comparison, right? So look at how wide those things are. But again, I'm not getting all of them. I'm not always getting it right. But if I only have 6 in my sample, then my confidence intervals have to be very wide apart in order to be able to capture that population mean. And most of the time it is correct. But I don't know, okay? If I just take one sample, if I'm just going back here, well, let's see, how wide are these? These are like from 40 to 64. So they're like 24 units wide, okay? So then if I have just one sample, reset this, I have one sample, and I say, okay, this has a mean of 38. So then I could have anywhere from 24 to 52. So that would be where I think the population mean is. It's somewhere in between there, 24 to 52. Wow. Well, the actual number was 43, so yeah, I got it. But I really don't know where it is very well with just such a small sample size. All right, so this is the concept of the confidence interval. Each sample that you get, when you're only doing one most of the time when you're doing a research project, you only do the sample one time and you say, these are the people that I have. And so I find the average of these people, however many there are. And then by using the mathematical formula, I get an idea of what the population number is based on just that sample number. So the population number, I say, is somewhere in the interval, in the confidence interval. And clearly, if I have a larger sample, I have more accuracy. I'm able to make better decisions when I have a larger sample. All right, so that's the concept of the confidence interval. And so then you'll need to look at videos regarding the technology that you're going to use to be able to know exactly how to find those numbers.